Bell curves, 10 exercises. So we're starting from the beginning. There's a household. The histogram shows how much electricity it uses. And there were 3 different years. The blue bars were 2017, then orange, and then most recently yellow. So in what month do they use the most electricity? We're just looking for when the bars are the highest. So here's the very highest bar. January could be a sensible answer. December has some spread. Maybe this family travels a lot in December, and some years they're home and some years they're not. It's hard to say. February is definitely a contender for second place. So I'll say January, February, December.
Mm.
In what month was the least deviation from year to year? So what month has the smallest amount of change? The bars look like they're the closest together. So there's
That looks like July.
July, yeah. I think the answer in the multiple choice says November or July, so you don't have to actually argue about it. July definitely looks good. So July or November. If someone asks, what is this household's typical monthly electrical usage? That sounds like a good question, but it's a little vague because it changes from month to month and it changes a bit from year to year. So if we wanted to give somebody a numeric answer, this many thousand kilowatt hours, then what would we need to make it meaningful? What kind of qualifications or caveats or clauses do we need to say?
Um, so just asking the typical monthly electrical usage is a bit broad. So I think narrowing it down to a specific year or a specific season would help.
Okay. Yeah, so specific year or season. That makes sense to me. Okay, moving onward, number 4 and 5. I bet we can fit those on one slide. When did this family replace their old electric furnace with a modern and more efficient heat pump? So their electrical use would go down a lot. So which year suddenly, or which month of which year did they suddenly get a big drop in their numbers?
It looks like probably December of 2019
Yeah,
because it suddenly dropped.
right there, there's a big drop, right? So probably December, I guess 18, because the drop continued the rest of that winter. There was a second
Yeah.
drop in 2019, but that didn't keep going as much. So something else was happening here. Maybe they were away from their house. Maybe the winter wasn't as cold. Something else is going on there. But the big forever after it dropped change seems to be after blue and before orange.
Yeah.
Okay, total electrical usage for 2017 was that many kilowatt hours. The total for 2019 was that many. So how much less electricity was used? Well, that's just subtraction. How much less, right? So 14, 780, 11, 513. I'm going to be lazy and use my calculator. 3,267. And that's kilowatt hours.
Yes. That's the number I got as well on my calculator.
Okay. At 6 on this slide. Yes. Maybe number. So for 6, we're going to take each of those kilowatt hours they didn't use and multiply it by the 11.3 cents. And we get $361.17.
Yes.
So that was their savings. And they could do that kind of math and say, oh, well, the heat pump cost this much. So we're saving about that much a year and like that. Okay, for number 7, what's the percent decrease when comparing these? So a percent change is change divided by original. The change we found was 3,267. And the original was the bigger one, 14,780. The original isn't always the bigger one, but in this case it is. And we get about 0.22. Then we need to make that a percent.
So to make that a percent, it would turn out to be 22%.
Yep.
That-
2% savings on electricity. Then it keeps going. In this city, %80 of electric power is from carbon-free hydroelectric energy, and the CO2 emissions are 16.2 grams for every kilowatt hour. So in 2019, what's their emissions? So 2019 was the 11,513. I'm just reading that from the problem before. And for each of those, they make 16.2 grams. So we get 186. 511 grams. Now the answer didn't ask for grams, it asked for kilograms. Right?
Yes.
So I need to go from grams to kilograms. So to rewrite things with more than you would want to actually write on your paper, we're now wondering this many grams is that many kilograms. We talked about this with the video yesterday. We're going to make our little killer hobos dance under dazzling crystal mobiles. This one is Pillow. Ecta and Dessa we never use. This is the plane unit. Dessa we never use. This is Sente.
That would be 1, 2, 3.
So we're going from the plane unit,
To go this way.
grams,
Okay.
all the way up. Yes,
So
you had it right the first time. So starting at the plane unit,
did I?
going up to kilograms was 3 to the left.
Which would be right here. Okay.
So 1, 2, 3. So our answer is about 187. I should mark that I'm rounding kilograms. We're almost done. A typical gasoline automobile's emission is 8.8 kilograms of CO2 per gallon. And that household's car gets 30 miles per gallon. How many miles would they need to drive to be equivalent? So the 187 divided by the 8.8. Let me write this right. 21.25. So that's how many gallons they got to use. And then for each of those gallons, we're going to multiply by 30 because each gallon lets them go 30 miles.
Okay.
So we get 637.5. So about 638. Not like the car is completely regular. So these numbers are for Eugene.
Okay.
Eugene is wonderful with having so much hydroelectric. And the moral of the story is that for almost every family, your home is not as big a deal as your car as far as global warming. Most people drive a lot more than 638 miles a year on their car.
Okay, that makes sense.
And then for number 10, that household actually drives 10,000 miles a year, which is the equivalent to about 333 gallons of gasoline, and do a bunch of math. So let's start a new slide and do all this. So they had 333 gallons. We know from the previous problem, each of those gallons was 8.8. So 2,930 roughly. Kilograms. Their house was 187. We add that together and we get 3,117. So that's kilograms of CO2. If we divide by 1,000, we convert from kilograms to metric tons. So let's do that. Divided by 1,000 is scooting 3 to the right. So we're going to get 3.117 metric tons. of CO2.
3.117 tons.
You've probably heard of
Okay.
carbon offsets. Businesses that make lots of smokestacks emissions purchase carbon offsets. So they are run about $14 for a metric ton of CO2. So
So
this
which-
family, if they wanted to do that, they would multiply by
Do you
14,
times it by the
Yep.
14?
because each one is times 14.
And then can I put down the answer that I got for multiplying those two?
Sure.
Okay. I got P 6 3 8.
Yep, and it's dollars and cents.
That was the number I got.
We should probably just say $43.64.
Yes. So that would be 40, 64, rounding up.
Mhm.
Okay.
Good job with a mouse. It's much easier with a stylus. So
Yeah, I don't have an external mouse, which is why it's so difficult. I'm trying to use a little laptop mouse.
mhm. Yes, I tried that for about 2 seconds once and gave up. So good job. Anyway,
Yeah, it's
Uh,
fun.
so the moral of this story is then that, yeah, for businesses with the amount of pollution that a factory makes, then carbon offsets make sense. For a family in Eugene, if you want to donate somewhere, 50, $100 to an environmental charity, then you can consider yourself balancing out saving the planet somewhat. Right? Morally gray issues, don't trust your math teacher, but there's the numbers. My wife is laughing in the chair next to me.
That's great.
Okay, I'm going to stop the recording.